following directly on from my previous video, we will now look at 4 further examples of non-homogeneous ODEs. We're just going to find the general solutions. We've got one more video in the series to come out, which we will look at particular solutions. Okay, so we've got the second order differential equation, and what we're going to do first is we're going to jump to the complementary function. For this course, there's only one method that is taught to teach a second order or higher differential equation. So as soon as you see a second or higher order derivative, you know it's going to be the auxiliary equation. Just jump straight into it. Lambda squared minus 10 lambda plus 25 is 0. Okay, please check previous videos out if you are unsure of exactly what I'm doing right now. Factorise that. That's going to give me a repeated root of 5. So once I've got a repeated root from an auxiliary equation, then I know that my complementary function, YCF, is going to be a linear function, a plus bx, multiplied by e to the 5x. Okay, so that's my complementary function. All right, particular integral. Now, for this one, we've got a sine function, which means our particular integral is going to have to contain a sine and a cosine function, because when we differentiate the sine, we get cosine, so we need to tailor for both. So let my ypi be equal to alpha times sine of 10x. Oops, right, that bracket shouldn't be there. And then I'm going to do plus beta times the cosine of 10x. And I need to differentiate that twice, so I can put this particular integral into my differential equation. So ypi primed is going to be 10 alpha times the cosine. I'm going to shorthand now. So sine differentiates cosine, so C is cos 10 alpha. That's like cos 10x. And then the cos is going to differentiate to a negative 10 sine. So it's going to be minus 10 beta times sine. And then ypi double primed, that cos is going to integrate to negative 10 sine. So that's going to be negative 100 alpha sine of x minus, and the 10 is going to come out there. So 100 beta cosine of x. Okay, so I've got my particular integral, its first and second derivatives, and I can now take these 3 definitions and run them through my differential equation and then force out this right-hand side. So, first derivative, that's minus 100 alpha sine minus 100 beta cosine. Then I've got minus 10 times my first derivative, so I'm going to do minus 10 times this one. So that's going to be minus 100 alpha times cosine. Then I've got plus 100 beta times sine. And then I've got 25 of my y. So I need to add 25 of this. As plus 25 alpha sine plus 25 beta cosine. And I want this to always be equal to the right-hand side, which is 625 sine. All right, start equating coefficients. So I can see I've got a sine here, a sine here, a sine here, and a sine here. So that's going to give me minus 75 alpha, because I've got minus 100 there, and I've got 100 beta there, 25 alpha there, so add them together, get minus 75. Then I've got plus 100 beta there, and I want that to equal the coefficient of sine on my right-hand side. So that's 625. And then I can do something similar to the cosine. So I've got a cosine there, a cosine there, and a cosine there. So that's minus 75 beta and minus 100 alpha. And I want that to equal 0 because there's no cosines on the right-hand side. Okay, this is a pair of simultaneous equations, which I can pop into my calculator. Okay, so equation mode, simultaneous F2. The non-graphical version of this calculator can solve these as well, or you can just solve them manually, it's also fine. So minus 75 alpha plus 100 beta is 625. That's my first equation. Second equation, minus 100 alpha. Make sure you get them in the same columns. minus 75 beta is 0. So that gives me alpha is minus 3 and beta is 4. So alpha is minus 3 and beta is 4. Then I can use those two definitions in one particular integral up here. Okay, in previous videos, I then wrote the particular integral, but I'm not going to bother in this video. I'm just going to jump straight from that to the general solution. So therefore, the general solution of this differential equation is going to be y is equal to my complementary function part, which is a plus bx times e to the 5x, plus my particular integral part, which is up here, with these two numerical values for alpha and beta. So I'm going to get minus 3, because alpha is negative 3, times sine of 10x. And at this point, because it's an answer, you should definitely write the full trig function. Don't shorthand it. And then I've also got beta, beta cos 10x, but beta is 4. So that's going to be plus 4 times the cosine of 10x. And that is the general solution to the differential equation. Okay. Second example. Okay, this time we've got x's as functions of t. Okay, not y's as functions of x's. Okay, x is our dependent variable and t is our independent variable. Okay, so this is a second order equation. We can jump straight to the auxiliary equation. So in this case, that's going to be 4 lambda squared minus 1. There's no dx by dt term, so there's no lambda term in my auxiliary equation. That's going to equal 0. So that's going to give me that lambda is plus or minus 1/2. Okay. Now I know that sine and cosh functions will satisfy this, but we don't use sine and cosh on this course for this. We just stick with the e's. It's because we are doing MEI further maths. Okay, in case you're watching and you're not studying that course. So that allows me to state that the complementary function is some arbitrary constant e to the t on 2 plus some other arbitrary constant e to the negative t on 2. Okay, so there's my complementary function. All right, particular integral. Now this one, this right hand side, is a combination of a quadratic and an exponential. So my PI should contain a quadratic and an exponential. So I'm going to say x PI is equal to alpha t squared plus beta t plus gamma. So there's my quadratic for this term. And then I've also got this exponential term. So that's going to be delta e to the t. Okay, if that was a 2t, then that will come down as a 2t, etc. Okay, so that's my general form for my particular integral. None of this is part of my complementary function, so I've got no issues. So this should work. So differentiate that. In fact, I only need to differentiate it twice because there's no x dot term in my differential equation. So I'm going to jump straight to the second derivative. Second derivative of this quadratic term is 2 alpha. That's going to go to 0, that's going to go to 0, and that just remains as it is at delta e to the t. Okay, now taking these two definitions and running them through this differential equation, that will allow me to equate coefficients and find numerical values for alpha, beta, gamma, and delta. So 4 times x double dot, so that's going to give me 8 alpha plus 4 delta e to the t. Okay, so that's 4 times my second derivative. And then I've got to subtract my function. So it's going to be minus alpha t squared minus beta t minus gamma minus delta e to the t. And I want this to be identical to the right hand side, which is 2t squared plus e to the t. And now I can equate coefficients just as I did before. So looking at my coefficients of t squared, that's going to give me that minus alpha on the left hand side is equal to 2. That tells me that alpha is negative 2. Constant terms, that's the only constant term, so I can just state that beta is 0 because there's no constant terms on the right hand side of my equation. What else have I got? Sorry, linear term, not constant term. My constant term, I've got an 8 alpha here and a minus gamma here. So t to the 0 is going to give me 8 alpha subtract gamma, and I want that to be 0 because there's no constant. But I know that alpha is minus 2 already, so I've got minus 16 minus gamma must be 0. So that tells me that gamma must be negative 16. And then one final term, I'm running out of colours here, just the exponential term, which we can see don't interfere with the polynomial at all. They are kind of very distinct. So e to the t term, I've got 4 delta minus a delta, so that's a 3 delta here, and that's going to equal 1. So that tells me that delta is a third. Okay, so there's my numerical values for alpha, beta, gamma, and delta. So I'd put those into this line here to give me my particular integral. Okay, I'm not going to do that though. I'm just going to go straight to my general solution. Okay, so therefore y is equal to my complementary function, which is a e to the t on 2 plus b e to the minus t on 2 plus my particular integral, which is alpha t squared, so it's minus 2t squared. Beta was 0, so it disappears. Minus 16, and then plus a third e to the t. Okay, that is the general solution of this differential equation. Okay. If I run these two through the left-hand side, it will always give me a 0. If I run these 3 through the left-hand side, it will always give me 2t squared plus e to the t. So when I run the whole thing through, then it'll always give me the right-hand side. Okay. Also contains 2 arbitrary constants. So it's general. Okay. Third example out of 4. Okay. Same process. Complementary function. In this case, the auxiliary equation is lambda squared plus 6 lambda plus 10 is 0. So that's going to give me lambda is minus b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. So that's going to give me minus 3 plus or minus I. And you don't have to use a quadratic formula, of course. You can just pop this straight into your calculator, and that will give you your 2 complex roots. So from there, we can jump straight to our complementary function. Y is a function of t. Okay, y, and then we've got t's on the bottom as derivatives and t on the right-hand side. So it's going to be y is equal to e to the negative 3t into a times the cosine of 1 times t plus b times the sine of 1 times t. Okay, so there's my complementary function. Okay, particular integral. Right, so I've got a trig function and I've got a linear function. So again, I'm going to need to include both of those. One thing I want to point out here is, yes, there's a sine t on the right and there's a sine t as part of my complementary function. However, this sine t is actually times by e to the minus 3t. So I don't need to times the particular integral by t to get it to work, because actually e to the minus 3t times sine t is different to sine t. Okay, so just so you're aware of that. So particular integral, I'm going to say ypi is alpha times sine plus beta times the cosine. Again, I'm using shorthand notation here. So those two are there because of the trig function. Also got a linear function, so I need a plus a gamma t and plus a delta. Don't forget to include your constant. Even though there's not one here, I still need to include it, because when I differentiate that, I'll get a constant, so I need to deal with it. Okay, I need the first and second derivatives of this. So ypi dot is alpha times the cosine, because in this case, the coefficient inside the sine function is 1, so it doesn't times by anything. Minus beta times sine plus gamma, and then ypi double dot is going to be minus alpha sine minus beta cosine, and then the gamma disappears as well at that point. Okay, take those 3 definitions run them through my differential equation, and we will get values for alpha, beta, gamma, and delta. So I want the second derivative. So I'm going to get minus alpha sine minus beta cosine. Then I want 6 of the first derivatives. So I need plus 6 alpha cosine minus 6 beta sine plus 6 gamma. Then I want 10 of the function itself. So that's going to be plus 10 alpha sine plus 10 beta cosine plus 10 gamma t plus 10 delta. And that needs to always be equal to the right-hand side, which is 78 sine plus 50 t. Okay. And because I want this to always be equal to that, then I can equate the coefficients. So let's look at the coefficients of sine. So I've got a sine function there, sine function there, a sine function there, and a sine function there. And that's going to give me minus alpha plus 10 alpha, which is 9 alpha. I've got minus 6 beta here, and I want that to equal 78. Let's look at the coefficients of cosine. So I've got one here, and one here. There's nothing on the right-hand side for cosine. So I've got 10 beta minus beta, so that's 9 beta. And then I've also got a 6 alpha, and that's going to equal 0. That's a pair of simultaneous equations. So get my calculator back. Right, 9 alpha minus 6 beta, I want it to be 78, and then 6 alpha plus 9 beta is going to be 0. So that gives me that alpha is 6 and beta is -4. Okay. Now I need to do the linear functions. So I've got, I'm going to circle these ones. There's a linear function there and a linear function there, or coefficient of t, if you like. So according to my coefficient of t, I've got 10 gamma must be 50. And that tells me that gamma is 5. And then my constants, I've got a 6 gamma there and a 10 delta there, and that's going to be 0. So t to the 0 is going to give me a 6 gamma plus a 10 delta is going to be 0. However, I already know that gamma is 5. So I've got 30 plus 10 delta is 0. So that must mean that delta is -3. Okay, so there's my numerical values for alpha, beta, gamma, and delta. I can put those into this to give me my particular integral, and then I'll take my particular integral, add it to my complementary function for the general solution. That's what I'm going to do now. At the bottom of the page here, let's have y as my general solution is going to be e to the minus 3t into a times the cosine of t plus b times the sine of t. And then I'm going to add my particular integral, which is alpha times sine, so that's plus 6 sine of t, plus beta times cos, that's minus 4 times the cosine of t. I've got then plus 5t, and then I've got plus delta, which is -3. And that is my general solution. All right, and one final example for this video here. Oh no, I've got 2 questions here. Okay, so it's a second order differential equation. I'm going to go through these a little bit more quickly. So lambda squared plus lambda equals 0. It's my auxiliary equation. So lambda is plus or minus I. So that tells me that xcf is a times the cosine of t plus b times the sine of t. Okay. Now for my particular integral, I would try x pi is being equal to alpha times sine plus beta times cosine. But I got an issue because alpha times sine is actually already part of my complementary function. So I know straight away, without even trying, that that's not going to work, because when I run this through, that's going to kick out 0. Also, the beta cos is going to kick out 0 as well. So this particular integral will not work. In an exam, if you run it through and you find it doesn't work, then you can then move on to how you would deal with that. But it is obviously quicker if you spot it at this stage, and then you haven't wasted any time. So actually the one we're going to try is xpi is equal to alpha t times sine plus beta t times cosine. Okay, the rule is that if a particular integral is going to fail, you times it by t and then try again. If that fails, you would then times it by t and try yet again. And you keep going until you get to a particular integral which will work. Okay, so this is the particular integral we're going to try. Now to differentiate this twice, I'm going to need to use the product rule quite a few times. Okay, so I'm not going to skip straight to the second derivative as I did in an example a couple examples ago. I'm going to actually evaluate the first derivative as well. So x dot pi, I'm just going to write down the answer. So it's going to be alpha t plus beta times the cosine. So I'm going to get a cosine function from here and then from here. And then I'm also going to get plus alpha minus beta t times the sine. And again, I'm going to get a sine function from this product and from this product. Okay, so that's how I obtained that. And then if I differentiate a second time, x double dot pi, I end up with, and feel free to pause the video at this stage and just check this, 2 alpha minus beta t times the cosine, and then I've got minus 2 beta plus alpha t times the sine. And I am just reading off a crib sheet for those. I'm not doing that differentiation in my head. Okay, so I had done these previously. Okay, now take these three definitions, oh, actually just the top and bottom definitions, and I'll put them into my differential equation. So that's going to give me the first derivative, which is 2 alpha minus beta t times the cosine, and then I'm also going to get plus the function, so I'm just going to put plus beta t times the cosine. So I'm doing the bottom line plus the top line, but I'm just combining the cosines together in one step. So that plus that is in there, and now I'm going to do the same thing with the sine. So it's going to be that plus that. So I'm going to get alpha t and then minus 2 beta minus alpha t times sine. And I want this to be identical to the right hand side of my differential equation, which is 4 times sine of t. Okay. Clear to see that the beta t's cancel, and so do the alpha t's. Okay, which is good because I haven't got any t sines or t coses on the right hand side. And they've only cancelled because that was part of my complementary function. So the coefficient of cosine then becomes 2 alpha on the left and 0 on the right. So that tells me that alpha is 0. And then the coefficients of sine on the right, on the left I've got minus 2 beta, and on the right I've got 4. So that tells me that beta is negative 2. Okay. Now I've got alpha and beta, I can write my general solution because I've got my complementary function as well. So my general solution to this differential equation is x is equal to my complementary function, which is, I'm going to write it as a, and beta is the coefficient of sine, so cosine. So I'm going to get minus 2t times the cosine of t plus b times the sine of t. Okay, so what I've done is I've factorised the cosine function that was part of my complementary function and part of my particular integral here, just to shorten my answer a little bit. You wouldn't have to do that. In an exam you could have all 3 terms, of course, unless the question asks specifically for it in a particular form. Okay, and my final example is a third order differential equation. So complementary function, I'm going to jump straight to the auxiliary equation. So that's going to be lambda cubed minus 3 lambda squared plus 4 equals 0. Okay, third derivative minus 3 times the second derivative plus the function. So that's going to give me this cubic. And again, I'm just going to be a little bit cheeky and jump onto my calculator at this stage. And I'm going to go into my polynomial solver. So F2, it's a degree 3 because it's a cubic. And I'm going to punch in my coefficients. So it's got a coefficient of 1 for the cubic term, -3 for the quadratic term. There's no linear terms, that's a 0. And then there's 4 for my constant term. And that gives me that there's 2 roots at 2, and there's 1 root at -1. So lambda, therefore, is -1, 2, and 2. Those are my 3 my 3 roots of this cubic. Okay, so that allows me to state the complementary function of this differential equation as being e to the minus t. Okay, y is a function of t, not x, so just be careful. E to the minus t. And then I've got a repeated root, so I need a linear function. So it's going to be b plus ct e to the 2t. Okay, so there's my complementary function. Now, my particular integral. Typically, we would have tried y pi is equal to alpha e to the 2t. However, I can see that that's not going to work in this case because I've got a constant times e to the 2t as part of my particular integral, my complementary function. So it's not going to work for my particular integral. So that's not going to work. So reject that one. When I reject a particular integral form, I'm going to times it by t and try again. So this time it's going to be alpha t e to the 2t. However, this is not going to work either, because in this case, I also have a linear function times e to the 2t as part of my complementary function, which is exactly what that is. So therefore, that is also going to fail. So I times it by t again. So ypi is going to be alpha t squared e to the 2t. And that is now not part of my complementary function. So therefore, I can now run with this. Okay. This is why it's important you do the complementary function first, so that you can spot when a particular integral will fail. Okay, right, now, given this definition of ypi, I need to find the second and third derivatives. So again, I've done this beforehand, but you would actually need to kind of plough through all this if this were an exam question. So the second derivative, so ypi double primed, that is, and feel free to check this, 2 alpha into 2t squared plus 4t plus 1 times e to the 2t. And then ypi triple primed, that is actually 4 alpha into 2t squared plus 6t plus 3 e to the 2t. And again, I've not done it in my head. I have done this before I am recording. Okay, now I'll take these 3 definitions, the function, the second derivative and the third derivative, and I'll run them through my differential equation. And then I can equate the coefficients. So, one of these, so that's going to be 4 alpha into 2t squared plus 6t plus 3 e to the 2t. Minus 3 of my second derivative, so minus 3 of these. So it's going to be minus 6 alpha, 2t squared plus 4t plus 1. Got 4 times my function, which is here, so that's plus 4 alpha e to the t squared e to the 2t, and I want this to be identical to 30 e to the 2t. Okay. Right, the t squareds, I've got 8 over here, or technically 8 alpha, minus 6 alpha here, and then, minus 12 alpha there, because it's 6 times 2. And then I've got plus 4 alpha there, which is 0, which is good. Okay, so those all cancel with themselves. And the t terms, I've got 4 times 6, which is 24 4 alpha. And then I've got minus 6 times 4, which is minus 24 alpha, which is also 0, which is great. So those two are going to cancel. And it's great because I haven't got any TE to the 2T on the right. So I need it to be 0. And these have only come out to be 0 because the first two failed. Okay. And then finally, the coefficient I want, which will allow me to find alpha. 4 alpha times 3, so that's going to be 12 alpha. Then I've got minus 6 there, so that's minus 6 alpha, and that's going to equal 30. It's actually the coefficient of e to the 2t times t to the 0, isn't it? So maybe I should put that over here. Okay, so that gives me an equation for alpha. So that tells me that alpha is 5. Excellent. Okay, so now I've got my particular integral, after a little bit of work there, and my complementary function. I can then state my general solution. So that tells me that y is my complementary function, which is e to the minus t plus b plus ct times e to the 2t, and I've also got this one, which is plus 5t squared. So I'm going to write it as b plus ct, which are the two pieces from my complementary function, and then I've got plus 5t squared, which is from my particular integral, because alpha is 5, and that's times e to the 2t. And that is my general solution. Okay, this one, because it's a third order equation, requires 3 arbitrary constants, and we can see I've got an a, a b, and a c. So I've got 3 arbitrary constants. Okay, right, hope that was useful. That was obviously 5 examples there of non-homogeneous differential equations. If you've got any questions on anything I've said, or you think you've spotted a mistake, then please just drop a message in the comments. And check out other videos in my channel for help with your studies. Thank you very much for watching.